Now the case of secant function. Secant function for 1, 1, 1, 2. The 1, 2 secant function defined in we have done this earlier. So this is secant function from r minus set of Rx, where x equal to 2n plus 1 into pi by 2 into r minus 1, 1. The interval minus 1, 1. That is, from this domain, from R, in this domain we have no all multiples of pi by 2. From R, all multiples of pi by 2 are excluded. That is the domain. That is all multiples pi by 2, 3 pi by 2, etc. Minus pi by 2, minus 3 pi by 2, etc. Such points excluded. And from that R, for the range from that R, the interval minus 1, 1 is excluded. Minus 1, 1 not excluded, that points, 2 points not excluded, but the interval between this minus 1 and 1 are excluded. And now, this is 1, 2, but we want to restrict the domain so that this secant becomes 1, 1 in that interval, restricted interval. So for this, consider the domain and the range. So we draw the two number lines, one for the domain and the other for the range. So in this range, this point is 0 and here we have 1 and here this minus 1 and this range constitute these portions together the range. In between this minus 1 and 1, this open interval minus 1, 1, this portion is excluded. That is range. And now consider this. Here we have a 0. Suppose we divide this into pi, 2 pi, 3 pi, etc. towards the right, and minus pi, minus 2 pi, minus 3 pi, etc. towards the left, dividing this whole interval in such a way. And exclude from this the whole multiples, pi by 2. So here comes pi by 2, excluded, 3 pi by 2 here, excluded, 5 pi by 2 here, excluded, and minus pi by 2 here, excluded, minus 3 pi by 2 here, excluded, and so on. So those points, all the multiples of pi by 2 excluded. So the remaining will be this. So this function, secant function, is from this domain to this range, secant function. Let me know. And now consider the interval 0 pi, 0 to pi. This interval 0 pi. So that interval we may expand this for convenience. So this is pi, this is 0, and middle we have say pi by 2. Now consider the secant function from this interval, say this interval 0 pi minus, this point is excluded, minus pi by 2, 2, this r minus 1, 1. This is. Now we know the secant function is 1 by cos, cosine. Now consider this pi by 2, this particular point pi by 2. There is no secant function at this point is excluded, but consider this pi by 2, and at this pi by 2, the value of cosine is, cos pi by 2 is 0. So secant is 1 by 0, not defined, but we may say infinity. In the sense that infinity is not defined. And now suppose we advance towards this pi from pi by 2. For a nearer value for this pi by 2 to the right. Right means greater than pi by 2, and therefore that value comes in the second quadrant. In that second quadrant, the cosine is negative, and therefore secant is also negative. And a near point of pi by 2 means the value of cosine for that particular value will be almost equal to 0, and this means 1 by cos, that is equal to will be infinity, minus infinity, because in the second part the cosine function is negative. So suppose this is minus infinity and plus infinity. So here the quantity comes almost twice or to almost to this minus infinity. And advance, suppose we advance from pi by 2 to pi, the value of cosine numerically increases, and at this pi it becomes minus 1. Cosine cos minus 1, cos pi is minus 1. That means advancing towards this pi means the value becomes almost close to this minus 1, and finally attains this minus 1. When this cos takes pi, its value equal to this. And now similarly consider this towards left at nearer point to this pi by 2 to the left. Left value in the first quadrant cos is positive, so secant is also positive, and a closer value for this pi by 2, this will be almost plus infinity, and as advancing towards the 0, it reaches or advances towards this 1. So this is the case. That means in this interval 0 pi, this secant function defined is 1 1 1 2. This can be 1 1 and this is 1 2. All values, so in this range are images for some value in the interval under this function secant function. So 1 2, and also we can see that this is 1 1 also. For every value in this interval we can have a pre-image here that we can verify if needed. So this secant function defined in this interval is 1 1 1 2, and hence this was inverse, and this inverse is from this r minus 1 1 to this 0 pi minus pi by 2. So for the inverse, this is domain and this is range. So this is the inverse for the secant function in this interval. Similarly, we can have inverses in this interval pi 2 pi. We can define this pi 2 pi secant in this way and obtain 1 1 1 2 secant. So this will, in this interval, this will have inverse. Then 2 pi to 3 pi. Similarly, and towards left 0 minus pi 0. This will have inverse. Minus 2 pi minus pi. This will have inverse. All these inverses are the branches of this inverse function, inverse of secant. And in this interval, the secant function, that is this secant function. So this inverse, this is inverse, secant inverse. So secant inverse from this into this is the principal value branch, and the values are called the principal values. Similarly, as in the previous situations, we have seen in the case of sine, cos, tan, cot, etc. So this is the case. And now one more we have to discuss, which is cosecant, and that will be discussed in the next video. Okay.